the livestock that they work with as well. So Matt?
Yeah, turn your mic on for the, just for the audio.
Can everybody hear me all right? Yep. Good? Well, they got me all wired up now, so I got to be really careful what I say. So, glad to be here. Thank you all for coming out. And as John said, I'm Matt Booher. I'm the crops agent in the Shenandoah Valley. And over here, right under that speaker, is John Benner. He is the animal science agent in the Augusta office with me. And we'll both be around. John will be there after this presentation throughout the day. I'm going to cover some things about some testing that we did. And there may be questions about that testing. I'm not going to go in depth on the sampling and the testing, but if you have any questions, John and myself will be around, so make sure you speak to us afterward. But what I'd like to share with you today are the results of some fescue endophyte and alkaloid testing that we have done over the past several years. And what really started this effort with our office was that a few years ago I became intrigued with the fact that we talk a lot about fescue toxicosis in academia as extension agents, but very rarely do you actually hear livestock producers talk about it in the field, and very rarely do you hear about people actively managing for fescue toxicosis. A lot of times what I'd hear out there is that, you know, a farmer would say, well, I don't really know if I have a problem or not. Sometimes they'd say, I haven't seen any problems, so I don't worry about it. I've even had some go so far as to say, well, I'm not going to baby my animals. They can just deal with it. And my initial reaction when I'd hear these things was, wow, these guys have really become complacent about this issue. They've been living with fescue so long that they don't even realize what problems they could be having. But the more I heard people talk like this, you know how they say the more you hear something, the more you start to believe it. Well, I myself began to question, do we really have a problem in our area in the Shenandoah Valley? Or even do we even have the potential for a problem? Do we even have that much toxic fescue? So I began to look into that question a little bit, dug into the research that was out there, and there really wasn't that much research that had been done in our area. The best I could find was this extension publication, which says that sampling in the 1980s revealed that 75% of the fields surveyed had fungus present in 50% or more of the plants. And just to back up a second, in case you're not aware of it, fescue toxicosis is caused by alkaloids, which are produced by a fungus that infects most of our fescue in the south here, I would say. And what this publication is saying is that in the 1980s, 75% of the fields they surveyed had that fungus in 50% or more of the plants. I couldn't even find a citation with this publication to allow me to go back in and look into that research a little more, so this is all I had, and it really didn't cut it for me. I mean, that research was 30 years ago, and it doesn't say where the surveying was done, you know, how much of it was actually done in our local area in the Shenandoah Valley. So it didn't really do it for me, and that kind of led to this effort to do some testing on our own. And luckily we can do some of the same endophyte testing. There's labs around the country that'll do that. So what we did was we partnered in 2014 with 26 farms in our area to do some endophyte sampling or fescue sampling and tests for endophytes. Each of these stars represents one of the farms that we tested a pasture on. And this here is Rockingham County, Augusta County, Rockbridge County. And this spans about 60, 70 miles, so we took samples from farms across the whole Shenandoah Valley. These were fields that we felt really represented the majority of our livestock producers in the Shenandoah Valley. And they weren't out of the way, unmanaged fields. These were well-managed fields. Collectively, the farms that we sampled from represented about 10,000 animals. So these were some of our better producers, larger producers. What we did was basically we would go into these pasture fields, and there's a sampling protocol we followed where we went across the field and took so many fescue tillers, and you clip and keep the bottom 3 or 4 inches of each of those tillers. They have to be frozen or kept cold and sent off to the lab. And then they do a staining technique. Somebody else could probably talk about that more in depth, but basically this photo here is showing that staining, and that if the stain shows these squiggly lines here, you know that you got the fungus in that plant. So this was 2013 that we did this testing, and here are our results that we got. 65% of the pastures were 100% infected. 30% of the pastures were 80 to 90% infected. And we had one pasture that was a little bit lower at 50%. But this was very, very striking to me, because that's even worse than what that publication had said. And pretty conclusive that we've got the potential for a problem in the Shenandoah Valley, and maybe we could extrapolate that out to the rest of Virginia, but very striking to me. Let me back up a second. I kind of left it at that. We had a meeting with these producers, talked about the results, everybody learned something, and that was kind of the end of it in my mind. And then a couple months later, we're very close in Augusta County to the McCormick Farm Ag Research Station. David Fisk is here today. He runs that research station. And he gave me a call about 2 months after we had done that testing and had our meeting. And he said he had, I think it was 6 or 8 heifers that had come down with fescue foot, and he invited me to come down and take a look. And this is what that looks like. This is one of the animals that was a little further along. This is a classic fescue foot here. And Terry Swecker came up from the vet school, did some x-raying on those animals, and this is that one heifer that was in the previous photo. You can see here's these are the 2 front feet. This is a healthy foot, and then here is a real classic view of the vasoconstriction that fescue toxicosis is associated with. So right here, blood flows cut off to the hoof, and I think Terry said that this animal is probably just a couple weeks away from having that hoof actually slough off. So this was unfortunate, but very interesting. David and I were talking about it, and these animals had been on stockpiled fescue. We had a dry summer, and then a dry early fall, and then we got some really good rain, some good growing conditions, and David was speculating that maybe with all that lush growth very quickly, that the alkaloid content of that forage had spiked and had caused these animals to come down with this problem. And then I think David even suggested, well, somebody should test some of these pastures for the full course of a year and kind of watch how and when they spike, and when they're low, when they're high. And so that actually led to the desire to do a little bit more testing. And this time, what we decided to do was to test the actual alkaloid levels. So we know we've got endophyte out there in our fescue, but how much alkaloids are they actually producing, and what's that look like over the course of the year? So in 2014, we partnered with 5 different farmers, livestock producers in the Shenandoah Valley, ranging again from up here in Rockingham County clear down to Rockbridge County. And what we did was we selected 9 different pastures out of those farms, and we sampled alkaloids from spring green up clear through till winter dormancy that next winter. And some things you need to know about how we did our sampling. These were grab samples across the pasture. So we would just go across the pasture, trying to avoid areas that were a little abnormal, if there were manure patties or anything like that, and we would just pluck the forage, and that was what we would freeze and then send off to the lab. And what we did was we sampled only fescue. A lot of these fields had some other things in, orchard grass, timothy, some other species, but we wanted to test just fescue in order to give us a baseline for interpreting our results. And we also sampled in a way that mimicked how the animals were sampling it, or how the animals were selecting forage. So we would actually go up there to the pasture and just sit back for a while when we went to sample, maybe get our binoculars out and watch how the animals were selecting forage. And essentially what this came to mean was from spring green up through about late June, early July, the animals tended to eat the entire plant. Seed stock, whatever seed head was there, they ate the whole plant. And here you can actually see he's got a fescue seed head sticking out of his mouth. And I actually got a little bit of an obsession about going around trying to take pictures of cows with fescue seed heads in their mouths. But anyhow, this is what we saw. At this point in June, the seed stalk, the seed head, they're tougher, they're more fibrous, but they're still green, and it seemed like the animals were going ahead and taking that whole plant. As we got more into July, August, and that seed stalk and the seed head browned up, dried up, I think they became a lot less palatable. And if the animal had the opportunity to, and he could, they would stick their head down, bypass all that stalk material, and get down to the undergrowth. So right or wrong, that's how we sampled. I felt like it would give us a better indicator of what the animal was actually seeing. So we did these 9 pastures through the course of the season. What were our findings? This line here indicates the average alkaloid levels from those 9 pastures. Average those together. Over here on the left here, you see the ergot alkaloid concentration, which is in parts per billion, and that's what we were measuring. And the first thing you see is that there are some fluctuations here throughout the course of the season, from the 1st of May clear through to December, and we'll talk about some of those fluctuations a little bit. Whoops, went too far. What I would like to show you, though, is does anybody know what the threshold level or the accepted threshold level is at which we start to see toxicosis problems with livestock? Anybody venture a guess? Heard 200. Joe probably here says maybe 0. But 200. From what I saw, nobody can really agree on it, of course. But I saw a lot of research that showed 500, 700 parts per billion. So let's say, for the purposes of our interpretation here, that around 500 parts per billion maybe is the threshold at which we start to see animal issues. And the thing that strikes me right off the bat, and this is really the take-home point from this presentation, is look how high these levels are through the entire course of the season. I mean, it's maybe a little lower here right at green up, but it gets high quickly and it stays pretty high. And that's the main take-home point from our research here, was we have the potential for some problems. Now these dots here represent the individual data points, the individual pasture samples that we took all through the course of the year. And you can see that they are very variable. So at the same point in time, say May 15th here, you've got numbers ranging from 1,500 clear up to almost 8,000. That makes it difficult in my mind, because I start to ask, what's causing that? How can we ever make any sense of this? So it is very variable, but also note, even with all that variability, they're all pretty high. They're above that threshold level. What's causing that variability? There's a million different things that I'm not going to get into. We've got different fescue genetics, temperature and moisture we'll talk about, fertility, plant maturity. So lots of different things could be causing those differences. But the number one, the first conclusion that we drew from our work was that our fescue, at least in the Shenandoah Valley where we were sampling, is very hot. And we've got the potential for problems. Now what I'd like to do is to step away from that average pasture that we just looked at and actually look at two different pastures individually so that we can pull out some concepts. We'll call these for now the blue pasture and the red pasture. Okay. First thing I'd like to show you is this spike here on the blue pasture. What do you think might be causing that spike? It's early spring, early to mid-May. Anybody have any ideas what might be causing that real quick spike in alkaloid content? Nitrogen, yep. So that farmer had applied some spring nitrogen to that field, and compared to this field and compared to some of the others, quite a spike, and I think that's expected. That's one of the things they tell us is that nitrogen will cause a spike in alkaloids. These two spikes here, look back over my notes as we were doing this interpretation, and really these coincided with some really good vegetative regrowth that we had. We had a little bit of an abnormal summer. We got a lot of rain that year, and we saw some good regrowth, and that's what's, I would say, is causing these spikes here. These two drops in alkaloid content, that's when we started to actually dry up for the year. So that makes sense. The fescue plant was starting to go dormant and dry up, so alkaloid, the fungus and the alkaloids dropped as well. Any idea on the red farm here, the red pasture? We're out of here in September. What might be causing a real rapid spike in alkaloid content here? The nitrogen again. This red pasture is actually the McCormick farm, the one I was telling you about that had those problem heifers, and David had put nitrogen out there, puts nitrogen out there every year to stockpile, and that's what was going on there. On the blue farm, the blue field, he didn't do that, and even though it had that great big spike in early spring, not seeing it here in the fall. So, and then here's we're going into winter dormancy. But what really comes out of this, as I start looking at these fluctuations, is notice that the things that make the plant happy, the good management techniques, nitrogen, vegetative regrowth, so maybe we're clipping or bush hogging pastures, praying for rain, like all these things that give us better forage are also causing these alkaloid levels to spike. I want to give you a real good visual example of what we just looked at. This is one of the pastures that we sampled, and we actually worked with the farmer to go in and split that pasture. And in mid-May, we had him go in on the one side and bush hog, clip those seed heads off. And he kept it up pretty high, but he knocked off those seed heads just like they tell us to. And what we got was some really amazing regrowth. I said we had a pretty rainy summer, and that's just some beautiful forage in my eyes. That's what we want. And at the time I was thinking, this is great. I got this great nutritious forage out here. Compared to this here where we left it mature, better nutrient content. I'm going to get these alkaloid sampling results back, and this is going to say that this is lower because I've always heard that vegetative leafy tissue is lower in alkaloids. This is going to be great. I can show farmers this. Well, we got the alkaloid results back, and this was actually 3,300 parts per billion, and this mature one here was 14 parts per billion. Now, I'm not going to say that it's higher actually in vegetative material. They're all wrong. I'm not going to say that. certainly this could be higher. Your animal could be seeing higher alkaloid levels if he goes along and clips off those seed heads or something like that. But the point here is, regardless, this is very high in alkaloid content. Remember our threshold down there at 500 parts per billion. This is at 3,000. So that's really troublesome to me. I don't know what to recommend to people. So the point is, the things that we do that can promote better forage and better pasture can actually make the matter worse as far as this alkaloid issue goes. Okay, so practices that result in better grass growth can lead to increased toxicity. All right, so what I want to do now is show you some supplemental sampling data that we did. And here again is the graph here. It shows this average pasture. We have all the data points from all the pasture samples that we took. This 3,381 parts per billion number, that's one that was in our regular sampling. So that's one of the pastures that we sampled on a regular basis. This 346 parts per billion was just some supplemental sampling we did just to play around. And I'll tell you, this 3381 pasture, that was, again, just the fescue. Okay, we just sampled fescue. What do you think I did down here at this 346 part per billion sample that was different?
You got the clover as well.
He says you got the clover as well. There actually wasn't that much clover in the field, but you're right, I did sample everything that was there. So I was just walking along one day sampling this one, and I thought, there's a good bit of other stuff in here. I'll go ahead and sample this too just for the heck of it and see what we get. And that's amazing to me that we get 90% reduction in alkaloid levels just from the diversity of that pasture. And that to me is a real practical thing that we can always point to as a way to help manage this issue is dilution with clover, other species, so forage diversity in our pasture systems. Here's another example, 1789 with the fescue only sample, 418 with the diverse sample from that pasture. So very interesting. If I were to do this again, I probably would have done this on every single field rather than just on a couple of them. It's be good to see what diversity can do for us. Lastly, this dot down here, 150 parts per billion. You can't tell it, but that's actually a cluster of samples. I think it was 3 or 4, John might know, 3 or 4 different samples from fields that were max Q fescue, so the novel non-toxic type. And I don't have any doubt that those max Q fields were probably at 0 at one point. These had been in a few years. It could have been some sampling error, maybe some wild toxic fescue moving back into the field. But the point is that those novel end-of-flight fescues are doing what they say they're going to do. They're very low. And as I look at this sampling becomes very important because I know that if I use a novel end-of-flight, if I take fields that are potentially lower in alkaloid level and then I add clovers in, other grasses in, that I could potentially get some of my fields down below that threshold level and use those strategically in my operation during breeding or something like that. So I think this is some important work, and I think we could be doing some testing more widely on our farms. Take-home point is that pasture diversity is a great tool to dilute this fescue toxicity. So in summary, what have we learned from a season of testing alkaloids? One, we have the potential for a lot of end-of-flight infection. We have a lot of potential out there for alkaloid production and the potential for animal problems because of that. I also learned that there can be very large differences among farms. So your neighbor's place might be very, very different from yours. There's even potentially a lot of difference between fields on the same farm. And that's where I think some of the sampling comes in. We should maybe be doing some more on our own farms. And again, you can talk to John or I about how to do the sampling, what it costs, where to send it. And lastly, seasonal fluctuations in these alkaloid levels mirror plant growth. So if the plant's doing well, the fungus is doing well, you can be sure that you've got alkaloids in high part in that plant. Okay, Chris, where am I on time?
Good, you're good.
Okay, so I want to show you one more thing that maybe one of the other speakers might talk about, or maybe you have questions on. We also, in addition to the alkaloid testing, we did nutritive testing on all these pastures through the whole course of the season. And one of the things that stood out to us was on the micronutrients in these pastures, zinc and copper specifically. These white dashed lines here are the NRC requirements for zinc and for copper. And from our testing, we found that both zinc and copper run below those NRC requirements. We did this from May through July, and I think that could be very important. A lot of times copper is mentioned in conjunction with toxicosis problems. I don't know how well that's been backed up in research, but even if it's not, we know that we need to provide a good, complete mineral to our animals, and I think this demonstrates that. So, are there any questions about the testing that we did, the sampling? Any thoughts?
Do you think, I'm assuming that the test results that you found remnants of from the 80s are accurate, do you think that the fescue is self-selecting, so to speak, because the endophyte is supposed to be generous to the plant? Are the fields getting worse just by surviving?
Yeah, so his question is, we looked at that research from the 80s that said, I forget now, 75% of the fields sampled had fungus present in 50% or more of the plants. And he asked, does that mean that we're steadily increasing in our infection level since the 80s? And I would say, I don't think we can say that from what we've done. There's a lot of sampling error potentially in there. But one would think that if we're getting into hotter climate, potentially, it could be selecting for more infected fescue. But that's just my guess. There's individuals here who are much better able to answer that than me, and maybe they'll get into some of that. But yeah. Jim?
On that slide you're showing,
Yeah.
you made the comment that we need to have a good mineral in front of the cattle to supplement. What would the levels be in a good mineral? How much zinc and how much copper should we be looking for on that label?
I don't know that off the top of my head. I'm sorry. John, I don't know if you have any idea.
I mean, looking at your graph, you're 10 parts per million below the level, so just about a standard pasture mineral should be able to cover 10 parts per million for zinc, even less so for copper.
So you're saying just don't go with that trace mineral block or something like that, yeah.
White salt.
Yeah, don't get a white salt block.
Taylor, do you know what the levels are in the Amelia mineral mix?
I would be scared but I know because of the research and stuff on fescue and research done with getting zinc and other heavy metals in decayes on biosolids amended land they did increase the recommendation for zinc, copper, and a lot of minerals. But I think wish I had a tag.
I'll find one during lunch.
Yeah, I think I got an empty bag in my truck. My truck was parked in another zip code. I think they're approaching 2,000 parts per million, 1,500, 2,000 parts per million in a a lot of these minerals that are formulated in fescue.
Any other questions for Matt? We're going to take one more, then, because he'll be around the rest of the day. We'll have time. Go ahead, sir.
The slide showing so much more growth compared to the older growth that you see.
Yeah.
The 33 compared to 17 in parts per billion. Wouldn't that be, some of that effect would be so many more tons per acre? You would have more tons per acre on that left side than you would have on the right.
So you're saying more tons per acre in this vegetative?
Wouldn't that add to that parts per billion? Wouldn't it be
Well, it's a concentration though. So it's not, yeah.
Okay.
Right, so we could take that concentration and multiply it by the tonnage, and maybe you'd see how much actual.
We're going to have time for a couple more questions.
That the brush mixture that you tested,
Yeah.
was it primary clover with that? Or?
No, it wasn't. That was what was amazing to me, was it was just some orchard grass and timothy and ryegrass in there. I didn't even sample, it didn't have much clover in it.
Hey Matt, was there any correlation with pH?
I didn't look into that. He asked if there's any correlation in pH. I didn't look into that one.
What lab?
Oh, the lab that we had sent our samples to is Agronostics Lab in Georgia, and we can give you more information about that. There's several of them across the country that will do this. It's expensive. It's a little bit time consuming. You got to keep those samples cold in the field. Then you got to freeze them. You got to ship them on dry ice, at least for agronostics.
Can one of you three talk about the variation between labs when you test home fescue? I mean, is there a lot of variation from lab to lab?
There's a lot of variation. Most of the testing is done with one alkaloid, ergovaline. You hear a lot of talk about that. And for instance, the lab in Oregon, the lab in Missouri, the lab in Arkansas, they all differ, but the trends are the same. So it's called a bias. But yeah, there is lab-to-lab variation. Those numbers just look, those are some of the most toxic, those are high.
And we didn't continue this testing this past year, but we did at the McCormick farm.
Yeah.
We did some testing that was stone's throw away, and those numbers were much, much lower this year for whatever reason.
Yeah.
So,
And there aren't many labs, though, that do this kind of testing, total ergot alkaloids. Most of them will measure one alkaloid, so this is the standard lab. It's a good lab.
Any other questions? One more.
Is there any theory that maybe over time natural selection or even manual selection by the farmer can breed the cows to a point where they're not susceptible to this?
I think someone else is going to cover that one, asking about the animal selection.
Touch base on that a little bit later.
Yeah.
Okay, Matt,
All right.
thank you. We appreciate it.